Well, good morning, everybody. I hope everybody's had a good morning. We're going to be in our workbooks on page 59 this morning, page 59, and it's Scaffolded Practice 1.3.1. What we're going to do today is we're going to try to walk through a scenario that we're given, an example, and we're going to create an equation and then graph that example. Now, we've done a little bit of this in 7th grade math, but we're going to get very involved with it in Core 1 as well as in your regular 8th grade math class. So what I want to do is just look at this scenario that we're given here. It says a local convenience store owner spent $10 on pencils to resell at the store. What is the equation of the store's revenue if each pencil sells for 50 cents? And then graph the equation. So we want to answer this question, what is the equation? And then we want to graph that equation. We want to do those two things. Now there is a series of 6 steps here that are suggested in order to do both of those things. Number 1, it says to read the problem and then reread the problem, determining the known quantities. Okay, so I've read the problem. I want to come back through and say, okay, a local convenience store owner spent $10 on pencils. Okay, so I could say that the initial cost of the pencils is $10. $10 for the pencils. And then, what else do I know? What is the equation? What is the equation of the store's revenue if each pencil sells for 50 cents? Okay, so the charge per pencil equals 0.50 cents. Okay. So I know my initial cost of the pencils. That's how much it cost this convenience store owner to buy the pencils. It was $10. I also know that each pencil is going to sell for 50 cents. So he's bought pencils for $10. He's going to sell them for 50 cents each. I almost would say we want to know what are the unknown quantities. I don't know the quantity of pencils. I don't know the quantity of pencils. And if I don't know that quantity, I may have to use a variable to represent that. Okay, so step number 2, identify the slope and the y-intercept. Now the slope equals a rate. It's a rate at which something is changing. And there's lots of different ways that you can talk about slope. You talk about slope a little bit in 7th grade class. It is absolutely huge when it comes to 8th grade math and also Core 1. We could think about slope as a rate of change. We could think about slope as the change in your dependent variable over your independent variable. You can think about it as delta y over delta x. There's lots of different ways to think about slope. But what we want to do is we want to say, are there any rates in this scenario that we presented? And we do have one right here. It says charge per pencil is 50 cents. So every time somebody comes into the store and buys a pencil, we're going to have our revenue increase 50 cents. And so I'm going to say that my slope is going to be 0.5. Slope is going to be 0.5. Now, how about a y-intercept? The y-intercept I shouldn't use an equal sign there. The y-intercept equals an initial amount. I'm sorry for my handwriting. I'm trying to write and talk fast. The y-intercept is any initial amounts that we have in the problem. We do have an initial amount. It's the cost of pencils. It's $10. But think about this. These pencils have cost our convenience store owner $10. So should we represent that number with a positive number or a negative number? Since it's costing us $10, we ought to represent that with a negative. Our y-intercept is negative 10. Our y-intercept I know, don't laugh at my circling. Y-intercept is negative 10. Okay, so now we want to substitute the slope and the y-intercept into the equation y equals mx plus b, where m is the slope and b is the y-intercept. So I'm going to write y equals, we've said that slope is 0.5, and I want to put that 0.5 where the m is in my slope-intercept equation. And so I'm going to put 0.5x. And that way that 0.5 is going to get multiplied by x. Every time somebody buys a pencil, it's going to be 50 more cents worth of revenue for our store. B is my y-intercept, so we're going to add b. Now we could do plus minus 10, but since we're snazzy mathematicians, we're just going to say that's going to be minus 10. And so one part of my original problem is answered. What is the equation of the store's revenue? It's right there. This right here is my equation. So I'm halfway to my answer. I've written an equation. Now I need to concern myself with graphing that equation. First thing we're going to do, we're going to change the slope into a fraction in preparation for graphing. That might seem like an unnecessary step at the time, right now, but you will see later that that becomes really handy to have your slope-intercept form with a fraction here instead of a decimal. This is not wrong. That is an accurate equation. But this one right here is going to allow you to see slope clearer. And so I would get used to writing y equals mx plus b, where m is represented as a fraction. Okay. Oh, I guess I just did step 4 and 5. It says change the slope into a fraction in preparation for graphing. Would have helped if I had read the question correctly. But let's do this. 0.5 equals 1/2. And then this right here should be my answer to number 5. Rewrite the equation using the fraction. So I've got an equation set and ready to go. So now I am ready to graph this thing. And they have given us a coordinate plane where all of our x values are positive. That's a good reason for that. We don't want to have any of our x values being negative because we're not going to sell negative pencils. We want to identify the independent and dependent variables. Okay. Think about it. Which one of these two variables is independent? And which one is dependent? Talk a little bit about this in 7th grade. But we can plug in anything we want, We can plug in anything we want for x. Because we can plug in any number of pencils, seeing that they're positive. We could plug in any number of pencils we want. Our result is going to be over here at y. And so your x, and this is a key thing to remember, x is always going to be independent. Your y is always going to be dependent. Your x is independent because we can plug in anything we want for x. Y has no choice what it's going to be because y is dependent upon what we plug in for x. And so x is our number of pencils. And y is our revenue. It's how much money we make depending on how many pencils we sell. And so what if we only sell, let's flip over here to this next page. This is now page 60. What if we were to sell, put an X right here and a Y right here. What if we were to sell 0 pencils? What if we don't sell a single pencil? How much money are we going to make? Take a second and answer that question. What if you plug in X? What if you plug in 0 for X? Remember, our equation is y equals 1/2 x minus 10. And so if we plug in 0 for x, that's going to be 1/2 times 0, which we know is 0. And so we're going to have 0 minus 10. Let me do that step here because you guys are probably very, very good at that. But instead of just talking through it, let's walk through it. The 1/2 times 0 is 0, and so we would have y equals 0 minus 10, and then y equals negative 10. So if x is 0, y equals negative 10. Well, what would happen, let's just grab a couple of points here. What if we plugged in 2 pencils, 4 pencils, and 6 pencils into our equation? Let's see if we can do mentally what would happen right here. What if we plugged in 2 right there for x? 1/2 times 2 would be 1, and so 1 minus 10 would be negative 9. And that makes sense. $2 or 2 pencils at 50 cents each would generate us $1 worth of revenue. And so now we have offset $1 of our cost with $1 of revenue. If we plug in 4 right here for x, it's going to be 1/2 times 4, that's 2. Minus 10 is 8. If we do that again with 6, 1/2 times 6 is 3. Minus 10 is 7. Okay? And so we have a table of values here. You don't have to plug in the same numbers I did, but I would suggest that you definitely plug in 0, because it's a good question to ask. What would happen if we sold 0 pencils? Because that's going to tell you your initial amount, or it's going to illustrate your initial amount. So we've got 0, 2, 4, and 6, and we've got the results negative 10, negative 9, negative 8, negative 7. Now I'm going to flip back over here just one quick moment, because their next question, or next point, says connect the points with a line and add an arrow at the right end of the line to show that the line of the equation goes on infinitely in that direction. Be sure to write the equation of the line next to the line on the graph. So let's take our points of 0, 2, 4, and 6. If x is 0, I'm going to zoom in here just a little bit. If x is 0, our y, our output, was negative 10. And so we have 1 point right here. What happens if our x was 1? If we sold, we went from 0 to 2. What happened when our x was 2, when we sold 2 pencils? Remember, our revenue was negative 9. If our pencils, the number of pencils we sold was 4, our revenue was negative 8. If the pencils we sold were 6, our revenue would be negative 7. So do you see how that creates if you don't laugh at my line, I won't laugh at yours, promise. That creates a linear equation. That creates a line, and that line would continue out infinitely, always depending upon how many pencils we sell. Our instructions were to write the equation next to the line. And so let's do that. That line is y equals 1/2. Way to go there, King. Don't forget the x. 1/2 x minus 10. And that line represents the scenario that we've done. That's a long explanation, and you're going to get faster and faster and faster the more you practice that. And I'd like for you to practice today. I'd like for you to practice, this is page 61. This is page 61. I'd like for you to practice these 4 examples here, starting with example 2. I would like for you to look at these 4 examples here and see if you can do the same steps that we just did. See if you can create an equation, and then see if you can, on graph paper, graph out where that equation will be. And if you're not used to graphing, your first graphs are going to be very, very rough, and I don't want you to get discouraged over that. We're going to get better and better and better the more we graph and the more we write equations. So this is just a good first step. But we're going to end that right here, and I hope you all have a good rest of your day. If you go to the fair, stay safe. Feel free to buy me a Dr. Pepper if I see you there. Talk to y'all later. Bye-bye.